Welcome to my channel, Catalyst Medway, where we ignite understanding and make academic easier. In our today's class, we'll be talking about the nomenclature of organic compound. Nomenclature of organic compound serves as a very difficult tool to most of the students, and it depends on the way in which you approach it. That is how you understand it. First and foremost, before you can name organic compound, you should know that there are functional groups. There are different functional groups. Now, for better understanding of the nomenclature, you have to know the priority of these functional groups. If you are seeing two different functional groups, which one will serve as the parent name, which one will serve as the substrate? If you are seeing three functional groups in a compound, which one will serve as the parent name or which one will serve as the substrate? So to understand that, we have to know the priority or the order of the priority of the functional groups. Now, the order of the priority of functional groups are as follows. One, the one with the highest priority is the onion compound, followed by carboxylic acids, followed by carboxylic anhydrides, carboxylic esters, acyl halides, amines, there is nitrites, aldehyde, there is ketones, alcohol, phenol, thiol, amine, phenol, thiol, there is amide, there is imine, then after imine, then there is ether. Now, I want to note the order of their priority. This is the order of their priority, in the sense that if you are seeing carboxylic acid has priority over any other functional groups except the ammonium compound. If you are seeing acyl halide together with amide, acyl halide will be our parent name, whereby amine serve as substrate. If you are having aldehyde and ketones in a compound, the aldehyde will be our parent name, whereby the ketones serve as substrate. This is their order of priority. Now, not just knowing the order of their priority, you should know how they are represented, how each functional group is represented. Carboxylic acids are represented by carboxylic anhydride, carboxylic esters, acyl halide, where S stand for halogens, amine, nitrile, aldehyde, ketones, alcohol, thiol, amine, imine, ether. Now, not just only their order of priority, you should as well know how they are being represented. This is how each functional group is being represented. Now, we'll start with the nomenclature proper. Now, I would advise you that before you should be able to know the nomenclature in the correct manner, now take each of the functional groups. You should know their name if they are in the straight chain. You will know their name if they are in cyclic, and you will know their name if they serve as a substituent. What did he say? He said that in each functional group, know their name in straight chain, know their name in cyclic form, and know their name when they serve as a substituent. These are the three important, these are the three key points that we must take note if we are doing the nomenclature. Now, our first in the series here is we'll start with carboxylic acid. We'll start with carboxylic acid. We say we must know their name in cyclic form, their name in straight form, and their name if they serve as the word substituents. Now, in straight chain, carboxylic acid are being what name by replacing A of the parent name with OIC. You replace your parent name with what? OIC. Instead of having methane, you'll be having methanol. Instead of having butane, you'll be having butanoid. Instead of having propane, you'll be having propanoid. And that is when they are in the straight chain. You have your parent name with OIC acid. Now it's also that you might be having more than one functional or carboxylic functional group in a compound. Now you can be having di. And you know that the carboxylic functional group do not usually occur in the middle carbon. That's it in their straight chain. You can only have them more than twice if they happen in a cyclic structure. Now, for example, you can be having in this case now, we are having only two carbons, and we know that only two carbons is what? Ethane. So instead of ethane, since we are having carboxylic functional group, it will now turn to ethanoic acid. You can also be having with two carboxylic functional groups. In this case now, you will be having what? This is 1, 2, 3, 4. Normally it's supposed to carbon number 4 is what? Ethane. But since we are having carboxylic functional group, we will not change to what? Butanoic acid. But we are having two functional groups here. We will be having butan. Okay. Butan. Carbon number 1 and carbon number 4, there is carboxylic acid. So we have what? Butan 1, 4, dioic acid. Since we are having two functional groups again, we'll be having dioic acid. Citing the position of where the double bond, where the carboxylic functional groups are located. This is the simplest way that you can know the nomenclature of carboxylic acid if they occur in the straight chain. You can also be having something of this nature. Now, what you will have here now is that you count the number of the carbon you are having. This is carbon number 1, carbon number 2, carbon number 3, carbon number 4, and carbon number 5. And carbon number 5 is what? Pentane. So, but since we are having carboxylic functional group, it will not change to pentanoic acid. Another example again, you can be having something like this. Because see, each carbon, they are carrying the carboxylic functional group. So in this case, you will be having this ethane, parent name. But since we are having carboxylic functional group, it changes to what? Noic acid. So we are having ethane. Now, carbon number 1, carbon number 2, they are both carrying carboxylic functional group. 1, 2, dioic acid. Trivial name, we could call it oxalic acid. While if butane 1,4-diazoxide, we can also call it succinic acid. Now, this is how you can name the carboxylic acid functional group in a straight chain. Now, moving to the cyclic. In cyclic form, if they occur in cyclic, that is, if there is a ring in their structure, you will add carboxylic acid to the parent name. If you are seeing carboxylic functional group in the cyclic form, you will just add carboxylic acid to the parent name. Example, we know that this is cyclopropane as our parent name. Then, adding carboxylic functional group, I've changed it to cyclopropane carboxylic acid. Cyclopropane carboxylic acid. You can also be having something like this. Carbon number 4, 1, 2, 3, 4 is supposed to be cyclobutane. But since they are a carboxylic functional group there, if you will add carboxylic acid to it, since it occurs in the cyclic form. So if you have a cyclobutane, 1, 2, dial carboxylic acid. So once a carboxylic acid is occur or find in the cyclic structure, you just add carboxylic acid to the parent name. Don't forget cyclo should be in your parent name. Now you know that carboxylic acid only serves as a substitute for the onion compound. And one carboxylic acid serves as a substitute, you call it carboxy. As a substitute, it is called carboxy. But it only serves as a substitute for the onion compound, where the only onion compound that is higher to it in the periodicity. So that is how you can name carboxylic acid. In a straight chain, oic acid. In the cyclic chain, carboxylic acid to the parent name. While by as a substitute, you just call it carboxy. Up next is carboxylic anhydride. Now, we should know that anhydride simply means removal of the water. Carboxylic anhydride is being formed by removal of the water between two carboxylic acids. So, it is represented as now, it also has this name. If it occurs in a straight chain, normally it does not occur in a cyclic form. So it always has this name if it occurs in a straight chain. Okay, we can also have it in cyclic. Now, if it occurs into a straight chain, you will have anhydride to the parent name. If you are seeing carboxylic anhydride in the straight chain, you just add anhydride to the parent name. Anhydride to the parent name. For now, it can occur in two ways. Both this R and R. The R and R are what? Symmetry. You just call one name, then put anhydride to it. For example, you can have it something like this. You can see that the number of carbon before O is 2. The number of carbon after it is also 2. We can call this one as our symmetric anhydride. Since the number of carbon are the same thing, we just call one, then put anhydride to it. Carbon number 2, ethane. So this is ethanoid anhydride. Not say ethanoid anhydride. Since they are symmetry, ethanoid anhydride. Because they are telling you that this compound here is being formed by removal of water between two ethanoic acid. This ethanoic acid. Then you plus another ethanoic acid. Removal of water. We know that if you are removing water like this, we have removed water, we are left with the O, and then you can see that this structure and this one, they are being formed by reaction of ethanoic acid together, two ethanoic acid and removal of water. So once your R and R are symmetric, you can just pull one, then add anhydride to it. Now, you can also be having a case where our R will not be equal. For example, we could be having because here they are not symmetric. We are having two carbon before the oxygen and three carbon after the oxygen. In this case, now we have to turn each of the carboxylic acid. Here, this is carbon number 2. We will have ethanoic. Carbon number 3, propanoid, and hydride. Ethanoic, propanoid, and hydride. Since they are not symmetric, you must measure each part. Ethanoic, propanoid, and hydride. These are the name carboxylic anhydride in a straight chain and hydride. Now, what if they now occur in a cyclic form? If the R is now in a cyclic form, if they are now in cyclic, you just add carboxylic anhydride to the parent name. You add carboxylic anhydride to the parent name. For example, now it's also the same thing. You can be having symmetry of it and also unsymmetry of our hand parts. Now, if you take a look at this one, we are having propane here, we are having propane here. That means these ones are symmetric. But it is not propane again. Since we are having carboxylic functional group there, so this one, since they are symmetric, you can just have cyclopropane, carboxylic, and hydride. Since they are symmetric, cyclopropane, carboxylic, and hydride. You see, since it's occurring in a cyclic form, we bring carboxylic and hydride, not cyclopropane and hydride. No. It is only when they are in straight chain if you just add anhydride directly. But once they occur in the cyclic form, you add carboxylic and hydride. You can also be having shift like this. Now, we have what? Protein here, we have what? Butane here. Butane here. So, we'll be having what? Cyclopropanes, carboxylic, cyclobutane, carboxylic, then and hydride. Since both of them they are not symmetric and both of them they occur in a cyclic form, you must add carboxylic to each of them. Cyclopropane carboxylic for this one, cyclobutane carboxylic, then and hydride. So these are you can place carboxylic and hydride in a straight chain as well as in a cyclic form. They do not usually serve as a substitute for any functional group. Carboxylic esters. We say carboxylic esters are where the hydroxy group of alter carboxylic acid is being replaced by OR. Now, we should know that the carboxylic esters, they have two parts. There is NOx part and there is R part. These are the two parts that we have in carboxylic esters. All these parts here is called alkyl wet. And all these parts can be either on alkyl group or they can substitute it with other substances such as sodium or potassium, anyone. Now, we should know that you will call the R part first before you call the alkyl wet part. Your R part first before the alkyl wet part. If you are having C double bond like this, you should know that this one is what is carbon number one. Carbon number one is supposed to be methane. But since it is in esters form, you'll be having methyl wave. You can be having carbon number two, ethane. But since it is in ester form, you'll be having ethyl wave. And we said these are your parent name. These are the one that you will call last. You will mention the alkyl part first. Example, you can be having now, if you're having something like you can see that this is carboxylic ester because all this part here is our alkyl part and this is our R part. If you check here, our R part here is what? Carbon number 9 is methyl. And we said we must mention the hard part first before the NOx part. So here we'll be having methyl 1, 2, 3, carbon number 3, propan wave. Mention your hard part first before the alkyl wave part. So it also be having now you also be having something like this. You can see that the R part here has turned to sodium. So if you have sodium 1, 2, 3, 4, butanoate, carbon number 4, sodium butanoate. So these are you can name carboxylic ester. Divided it into the alkyl part and your hard part. Name your hard part first before the name your hard part first before the alkyl part. You could also be having something like this. Okay. So here you can see that our hard part have turned into a cyclic compound. Now, what compound is this? 1, 2, 3. Carbon number 3. And it's in the cyclic form and it's an alkane. It will now be what? Cyclopropane. Then 1, 2, 3, 4, 5. Carbon number 5 is pentane. Pental. Noise. So these are you can name the carboxylic esters. These are our first series in nomenclature of organic compound. Do well, subscribe, follow, like, and share. Meet us in part 2. Thank you.